My name's Abram Vanderfloot, and I'd like to share with you this idea I have of using Minecraft in the classroom. So, I've created Biology Land, and Biology Land can be used in two ways in the classroom. First, it can be used by the teacher to make what you'll see are monuments and quests to test students' understanding. The monuments can be used to teach content, and then the quests can be used to assess their knowledge. But of course, the end goal is that the kids make this themselves. So I did make two sample monuments and quests to kind of introduce to the ideas to the kids, so they can see kind of what the idea of Biology Land is. And then the purpose really is that they'll go on and make monuments and quests of their own, either working individually or in a group. So it's a way for them to create something, that they would use the textbook and other sources of information to make the monuments and build them, and make the quests. So here's like an example. So this is the Plant Cell National Monument, and the format will be similar. They come here and then they grab the book, and then they can read the book. And the idea is while they're reading this book, they're taking notes in their biology journals on their desk. So it is kind of taking the place of the textbook. They're not reading the textbook, they're exploring Biology Land, and they're learning the information about eukaryotic cells, prokaryotic cells, viruses, and so they'll take notes as they read through that. The difference is they're not using the textbook, they're using a video game. A little bit more fun. Then after they've got some of the basic information, then they'll hop on over and they'll study these monuments. And so the monuments, this is obviously a monument of a plant cell, and it's got all these labels on there. And then they read the labels and they take notes, similar to how they would in their textbooks. It's just on a computer game. It's a little more fun. And then they have to find a way into this monument here, and they're looking for openings that's large enough for them to fit through. Can't fit through there. Eventually they'll stumble upon this here. There's an opening. Oh, and there's a switch. They can go inside. And here they are. They made their way inside, and these are all the different structures found in a typical plant cell, and then they're labeled. So again, they'll take notes as they learn about the different parts. So again, it's really just a three-dimensional interactive version of a textbook. And so they find the signs, take notes, and sometimes there's cute little things for them to do, like the ribosomes are responsible for making protein, so they're told to push a ribosome. So if they push on this ribosome, out comes something, a piece of steak, which gives them protein. So that's funny, and also supports the idea that ribosomes make protein, and they'll be able to use that food later when they need it. So after they've explored the whole cell and they've learned about all the different parts, now it's time for them to test their knowledge. And so they can test their knowledge in the perilous plant cell pond. And so they'll probably should get their sword ready. And now they can go into this pond here that we created. There's this little pond, and there's a little entrance into the perilous plant cell pond. And so when they go in there, whoa, it's quite a drop. Oh, I lost a lot of health points, but there is always help along the way. And they open that up and they see, oh, a potion of healing and some torches, because they are underwater, so it's going to get dark. And so then they go through this underwater maze and they try to find their way out. Let's see, they'll need a torch because you can't really read, it's dark. Alright, so here they come to a four-way crossing. How are they going to find out which way to go? They have to use their knowledge that they just gained in the cell monument. So plant cells are this because they have a nucleus. They'll look through their notes, say, oh, no, prokaryotic cells don't have a nucleus, so it can't be that way. Eukaryotic cells, that's the one. So then they go through, oh, and they come to another place, another question. Which organelle breaks down materials for the cell? So they'll have to consult their notes, and oh, they'll find out it's the lysosome, and so they know to go right. And so the idea is that this is just another way to interact with the content. It's interactive, it's a video game, it's fun, but it's still assessing their knowledge and, interacting with the content. The long-term goal is that after the kids, work through the monuments. Oh, there's a zombie. Look out. After they work through this example that I created, the idea is that they make their own. So they'll pick a biology topic like mitosis, and they'll design okay, gotta look out for those creepers. Anyway, the idea is that they'll build monuments of their own. They'll choose a topic like mitosis, and then either working alone or together, they'll build another monument. There's one for DNA that one of the students has started working on. And so they build a monument, label it to teach the facts, and then they create some kind of adventure for the students to go in to test their knowledge. Let's see, this is, what's this one? This one is DNA. So this is one that a student has actually started. DNA, National Monument. There's the box, there's the signs to teach the parts of DNA, and then it looks like they started their quest, the DNA Dungeon of Danger. So anyway, that's how we can use Minecraft to teach biology. And what I'm looking for is a different version of Minecraft. The problem with this one is that there are certain controls that I don't want the students to have because, I want them to be able to explore and not destroy each other's materials. And so there is a special version of Minecraft called Minecraft EDU that was created for classroom teachers, and it's a special version that gives them more control, certain features that we don't have in the regular game. And so I'm looking for funding for that. It's it would be $41 to set up the server for the teacher to run, and then the license for each student is $18, $14 if we get more than 25 at a time. But I think that, piloting this, we should start small. So I figure $41 for the setup, and maybe 5 to 10 students to start trying this with. And so we need about $131 to start trying this out and seeing if it's something that works with our students, and perhaps we can develop into something in the future. So that's what I'm thinking. I hope you see the value in it and will support me in this project. Thanks for watching, listening, and let me know what you think. Bye.